Alright. So now we're going to begin looking at negative numbers as shown by this number line. And you can see this kind of connects to our coordinate plane. This would, this could just be an x-axis if you think about it. We have our 0 here in the middle, and we have our positive x values, if you want to say. And then behind the 0 to the left, we have our negative integers. Okay. So one term we want to be familiar with is this idea of opposites. Numbers that are the exact same distance away from each other from 0 but in opposite directions. And again, like always, at any point, pause the video for more understanding if you need to slow down. So here's an example of some opposites, okay? Here's a standard number line that goes to 7 in opposite directions. So if you circle the number 4 to the right of 0, you can call that positive 4 or just a regular 4. The opposite of a positive 4 would be the negative 4. And they're both equal distant. They're just both 4 spots away from 0, just in opposite directions on the number line. Okay, and you see a couple notes here. Negative 4 looks like a minus sign in front of it. We don't really say minus 4 when we're talking about negative numbers. We want to say negative 4. And this little sign here is a negative sign. And also, if you just have 4 by itself, that's the same as positive 4. So whether you say a positive 4 with what looks like a plus sign in front of it, or if a 4 has no sign, or any number for that matter, you assume the positive. And it only becomes negative when you put the sign in front of that. So you want to be comfortable saying opposites of a number. It's just like 7, and the opposite of 7 is negative 7. Or if you say negative 1,000,000, the opposite of negative 1,000,000 is 1,000,000, and so on. And the only other real target with this is to be able to identify objects within a number line, whether the number line goes vertical, like so, or horizontal. So I might ask you, where does the bird lie? Okay, and the bird is a positive 3. This looks like a y-axis, right? The up and down axis. It's just identifying points on a grid. It just so happens to be items, or in this case we have a scuba diver. So you can start to do estimates. Scuba diver looks like right between -1, -2. You can say -1.5. Or if I was asking you the bottom of the hand of the scuba diver, that would be -2, and so on. Okay, so we also want to be familiar with some keywords of opposites, sometimes in some real-world problems. So above is a positive keyword, below is negative. A loss, if you have a loss of something that's a negative. Profit, the opposite of a loss, is positive. Decrease means you go down, that's going to be negative. Increase is positive. Rise is a positive word that would go into a word problem related to negative or positive numbers, and fall would be its opposite of negative. Okay, and there's some others you could definitely think about that we've talked about in class. Okay, we also want to be comfortable comparing negative numbers. So here we have the same model that we looked at. 4 is the opposite of negative 4. And just a couple notes there. The negative numbers are going to be to the left of 0. Your positive numbers, or integers we want to say, are to the right of 0. And our integer definition is just right up top there. It's a whole number. That whole number could be positive, negative, or even 0 itself. And this last point at the bottom here we're going to play with a little bit. If an integer is to the right of another integer on a number line, it is greater. Okay? So as an example, let's look at a number line here. I just identified -4 and -2. Pick 2 random integers. And we need to say that -2 is greater than -4. And the rule or strategy we want to just go with is -2 is to the right of -4 on the number line. So if you look at the positions, -2 is to the right. Now, I think that's easy enough to know from positive integers. 5, a positive 5 is to the right of a positive 4. We know 5 is bigger than 4 from earlier grades. But the same rule applies in the negative integers. It can be a little tricky to think that -2 is bigger or greater than -4, because 4 sounds bigger than 2, but that negative sign really changes everything. So if you just want to keep in mind, if the integer is to the right of the integer, then it's greater than. If you want to use another strategy, whichever one would help you, okay, the bigger the negative, the smaller the number. Okay, so example, -8 is a bigger negative than -4, so it's a smaller number, so therefore it's less than the -4. And with these greater than, less than, or even equal to signs, you could read them both ways. So if we read from right to left, left to right, you're looking at a -8 that is less than -4. Therefore, the opposite is true. If you go backwards from right to left, a -4 is greater than a -8, because if you read it from right to left, you're looking at a greater than sign in that direction. Okay, and the only other thing we really want to look at is sometimes you'll look at problems where you're increasing by a certain integer or decreasing. So let's look at this first one up top. This could be a test question you might see. Increase -2 by 3. Okay, so you're going to be looking at -2. That's where you want to start. Okay, so whichever integer they give you first, that's your starting point, like a race or something. And you're increasing by 3. Okay, the word increase means it's getting bigger. Okay, if the number's getting bigger on a number line, it's going to the right. So that key word increase means we're going to move to the right. And by 3, we're increasing by 3. Well, that's the amount of jumps we're going to do. So if we start at -2, which is the first integer they gave us, we're increasing by 3. So 1, 2, 3. We end up at a +1, or +1, not a +1, but a +1 or just a 1. And that becomes the answer. Let's do the bottom prop one, which is kind of a bit of the opposite. Decreasing means we're going to move to the left. Okay, numbers get smaller and smaller, or if you want to say less than and less than, as you go to the left. So the question says to decrease -3 by 2. -3 is where you want to start. So I'll use a different color here because I kind of already did this one. Okay, so if we start on -3, we're decreasing means go to the left. Decreasing by what? 2. So move 2 jumps to the left. 1, 2. And wherever you end up, here we're at a -5, that becomes your answer. It's a bit like the addition or subtraction problem. If you're decreasing, you're actually subtracting. So if you start with a -3, you decrease by 2, you're going to get a -5. This equation here is a bit tricky to look at. We're not quite going to get that far this year, but you'll see a lot of that in 7th grade. So for now, we're just going to kind of use these keywords and use our number line to kind of guide us and help us with these kind of questions.